Oh, there you go. So we're going to conclude our series on rational functions. Again, if you guys have a question on it, do it. But, yeah, I'm just going to go through about 4 examples and so we can. Okay, so let's go ahead and share the screen. Back to this here. So. Okay, so let's go ahead and do a couple of examples. So how about let's go ahead and try squared. No. Let's do x plus 3 squared. Okay. So anytime you have something that look like can be factored, you probably should. Even if nothing drops out, you should still do this. Hey, look, we got a common factor here. So the x plus 3's cancel out, but we have 1 over x minus 3 with the caveat that x cannot equal -3 at this point. X can't be +3 either, but we have a hole here. One of the things I'm going to ask you is like, where is this hole? We're going to plug it in. So if x were to be -3, what would that look like? That would be -3 minus 3. Right? Start with $3 in debt, spend another $3, congratulations, now you're $6 in debt. So the hole is 6. Now, we don't have to worry about this original function so much anymore because now we know what to avoid. We're just going to graph over x minus 3, x not equal to 3. I'm not going back to this original function. This is a lot of extra baggage. Just going to look at this one. Okay, where's my vertical asymptote? So x minus 3, 0, x is equal to +3. Remember, you can't have an asymptote and a hole in the same spot. Fortunately, this is the +3 versus the -3. So if you find yourself like, I got a hole and an asymptote, pick one. It's not both in the same place. Now, it could be in 2 different places, that's fine. Not the same place. What about horizontal asymptote? What's the degree of the top? The degree of the top, 0. The degree of the denominator, 1. 0 is a smaller number than 1. Okay, so we have our line at y is 0. Right, so it's a smaller. So let's go ahead and sketch in our stuff here. Let's do this. So we have what do we have? We have when x was equal to 3, right? Asymptote. So then these are straight. What about a -3? Right, well then we had a 6, we got a hole here, right? There's a vertical asymptote. How about a horizontal asymptote? Is that equal 0? So we have notice where the crosses are. It's not anywhere near the origin. This is not a symmetric function. It's different on this side of the axis than it will be on this side of the axis. It might be symmetric around where this is, but we don't really have a word for that, so we don't have to worry about it. Okay. So now we're going to get some points in here, right? So what do we have here? X minus 3, that's our function. Okay. And pick your favorite number that's bigger than 3. So here's x, pick 4 and 5. So this is going to be r. This is 1 over 4 minus 3. This is 1. And this is 1 over 5 minus 3, which is half. Let's call this 1. So at 4 and 5, we have so here we this point, and it's going to our asymptotes. So now what about the other side? Pick your favorite number that's smaller than 3. 0. 0 is my favorite smaller. Okay? So this is 1 over 0 minus 3, which is 1 over negative 3. So we have a third. So that's twice as big as that. So and could you have picked other points? Absolutely. Could you have picked 3 or 4, 5 points? Yeah, absolutely. So we're going to have another thing. And there we go. The important thing with graphing these things is try to get a reasonable picture. I remember some students, if we have a big asymptote, a lot of times students will draw this. And I am a little exaggerated version of this. Bothers me a little bit. You know, your artwork should be a little bit better than this, although I do tend to forgive the first one that I saw. But what happens? What happens here? Is that a function? No, isn't. Why isn't it a function? Yeah, it's a vertical line test. I'm not saying I'm never going to lie to you, I will, but I'm not going to say graph the function and then laugh at you for saying, oh, that's not really a function. It'll be phrased like, is the relationship a function? If so, graph it. If not, say why not, or point to where it's not. I'm not going to try to trick you into doing it. I'm not going to do this much of a trick. So it's lying to you about like getting the initial conditions, and that's not really a thing that you guys have to do just yet. Eventually you will, not in this class. Okay, so that's pretty much the graph of this one. I had both an asymptote and a hole, right? I never look at this and say this is a hard function. So if I was looking at a problem, say graph this, I would look at this one and say this is probably one of the easier ones. So let's go ahead. Even though it does have two elements of difficulty here. But our second example. All right, let's see here. Tell you what,